So theirs is all a custom interface. It's all closed. It has bells and whistles and colored LEDs and so on. But we'll talk about the one that's open and that everybody can use. And so, of course, if there's time and people are walking around, a lot of people have sat down and we've used this and we built something. So we have 3 cars now. We only had 1 this morning. But the idea is these are little robot controls on that one side, and you can move the platform around. Down at the bottom, there's the temperature for your extruder, and you can start the extruder and all that. So it's really like, this is what it looks like when you're in the driver's seat of the printer, and then you bring something in here. It might be trellis, it might be whatever it is, and then you can move it around, you can position it the way you want it, and then print it. Now I'm going to have a commercial for mathematics here, which maybe I could have had a little bit earlier, and I'm not supposed to say that because some people are. So you can see the object drop in, and then you can move the object and all that. But I just wanted to say, maybe you hadn't thought of it. How do these computers actually get digital data and print things? And it's at least knowing a little bit about how that works. In other words, I don't know if you've ever thought about how your digital camera, how a computer can understand what a picture is. But a simple way to say about how a computer can understand what a picture is to think about a mosaic. And if you were describing positions, you could have an X position and a Y position, and you could describe any little square in a rectangle. And if you could give a color there with some code, then you've got a picture. So all that happens with 3D, and by the way, this was made on a 3D printer. The popsicle sticks weren't made on a 3D printer, but that illustrates a good point, that there are many things that you could make effectively on a 3D printer by just making the part that was custom. And this is actually for teaching math in developing countries, that and all they have to distribute is these, and these are actually funky sticks from Starbucks because they kind of match up with the popsicle sticks in India or something. I don't know, but we just found these and they work. So, so instead of going 2 dimensions, like playing Battleship on the floor of this thing here, if you have to go in 3 dimensions, you just need one more dimension. You say, we go over here, up here, and then this high. And instead of saying over here, up here, you have to say over here, up here, and then this high. And that you can get to any point in 3 space. And the way that works out for these printers is that there are 3 motors here that actually do that. And you can go poke around and burn your finger or anything, but you'll see the 3 motors that move the extruder head to any point, and up this high. And up this high is done on this axis. I just want to say a little bit about the history exhibit back there. It's like history and guts. On the far right is a guy wearing a blue shirt. His name is Adrian Bowyer. And he came up with this whole concept, which is called RepRap. And RepRap stands for Self-Replicating Rapid Prototyping Machine. And he had this vision about just changing manufacturing, where anybody who wanted a RepRap could have one. And the only agreement was if you got one, you had to build another one, and give it to somebody under the same conditions. And then his idea would be that would revolutionize manufacturing in developing countries, things like that. So that picture there on the bottom is the first example of a machine. There's the sort of parent and child machine. The parent's on the left, and every part on the right that isn't a standard hardware store part was built by the machine on the left. And the picture on the top is the first part of a 3D printer that was made by a previous 3D printer. On the left is just a blow-up of what the sort of anatomy and physiology of this particular robot is. Okay, now I'm going to wind this down here and just say, because I said I wanted to give a museum-worthy talk here, to talk something about the big picture. And these are books that I wrote and so on, but there are various points of where technology started to get into people's lives and maybe change the way they think about this thing. These were about personal computers. This was about computers in the arts. This is about robotics. And what I've been harping on is that a 3D printer is a robot. And I'll tell you what the 5 actuators are: the heater, the extruder, the 3 motors. This is really about how we actually had this pipe dream that we were going to build a museum on the campus of UCSD. We thought it would be really great if you could just come to campus and there would be this museum there, which was like an open house, like you had a person from the faculty that would show you what they were doing. And that's, So I do think that plenty of research institutions, not just universities, could take that idea. So here's some books that I think put this in context, and they've been very influential on me. This is Indra McEwen's book. I mentioned her before, and this is the book called Socrates' Ancestor. If you read Socrates' Ancestor, you'll be surprised to learn what the origin of the meaning of the word theory is, because you would probably never guess it. It's something that's made on a MakerBot. That is, to the Greeks, a theory was a spectacle about how something worked. And what we call theory, they called commentary. Those were words that you provided after the fact in the discussion of the theory, which was actually the object. So that book is full of just marvelous, brilliant insights like that. And the concept of isonomia, which is opposed to the notion of hierarchy. Isonomia is a social organization in which everybody has something to do, and they know what they have to do, and they don't have to be told what to do. It's sort of, the Greeks did a lot of things, but one of the things that they did was they would be just sat out on ships and found colonies and things like that, and they didn't have these hierarchical systems. So anyway, it's really a primer, and most people wouldn't even think that Greek culture and Greek civilization existed before Socrates. And Socrates' ancestor actually refers to Daedalus, who could actually fly. And, well, in the legends he could fly. He was actually an expert shipbuilder and sailor. But Socrates has a famous quote that he's useless, Socrates, because he just plays with words, whereas his ancestors were actually able to build things and make them work. So this is a book called Vehicles by Valentino Bradenberg, and it's a really interesting book about starting from just very, very simple devices, like a little platform that has wheels that go, and then make it a platform with wheels that go, but a light sensor, so that when it senses light, one wheel turns a little faster, and all of a sudden it's a creature that seems to be going towards the light. And it goes up to about 15 stages of devices, and it's something about the evolution of psychology and the evolution of our interactions with devices when they stop being sort of machines and they begin to feel like pets or dogs or cats and things like that, and they begin to behave and change. This is The Forest Unseen, which is a wonderful book, but MakerBots and things like that are really part of a sort of be here now kind of movement that's going on, to say that if you like it, why don't you build it? Why don't you learn how to build it? If you like it, why don't you actually observe and see what's going on? And this is a square meter of forest for a year. That's what this book is about. And I think it's just relevant to so many things. This is Walter Ong's book, which is a famous book called Morality and Literacy. Ong was the guy who discovered, or sort of made the case the most strong that everybody began to believe it, that the Iliad and the Odyssey were not written by Homer. In fact, they were not written by anybody, but they were oral tradition, ballads and songs and so on, that were composed in a form that was memorable to be sung by many different people and so on, and then at some much later time, they were composed into written form. But his book, and the point of his book, was that there's a different way of thinking between an oral culture and a literate culture. And, this is in part a part of Edward Wilson's message too, that biological organisms build environments, and then those environments build the biological organisms. So there's a sort of dialogue between the kinds of things that we make and the way we communicate and the way we actually think. And it's not just one way, not just a one-way street. And Edward Wilson's book, in some ways, is a pessimistic book. Edward Wilson is one of those people who's not sure that our social mechanisms are going to be able to evolve as rapidly as our ability to kill each other and things like that. So we've got a lot of sort of hardwired things in the way we defend territory and do a lot of other things that really don't seem to have kept up with our ability to wreak havoc. These are the flowers at Lyle Point. Lyle Point is the place where the smallpox blankets incident occurred. Well, some of the Native Americans and so on that are in our group, they live there by Lyle Point. And that's why New Blankets is called New Blankets. The idea is that, technology can be used in a lot of ways, but if all that you're reading is, better robots make better drones and things like that, there ought to be something more to it. So that's what New Blankets is about. Thanks a lot. We got more info.